So we just left Benson Wood's 100,000 square foot systems facility where they build all the floor systems, wall systems, and roof systems. And we're gonna walk you through, if you guys can stick around, it's a long video, but we're gonna walk you through the entire process from when that material comes in raw, all the way to the end of the line where they're shrink wrapping some of the most high performance panels in the building industry. Guys, we're in Keene, New Hampshire this morning, and we're gonna be checking out Benson Wood's production facility. I got Jay right here. Jay, good to see you, man.
Morning, Nick.
So we are in the Keene location.
Yep.
What do we got going on around us? And we're gonna do a tour, but give me the quick overview.
So this is our Keene facility. It's about 120,000 square feet. And what we're building in here is all of our insulated walls, roof, and our floor components. And that's all with our windows and doors installed here in the factory.
So you have 3 divisions, right? You got the Benson Wood, Unity, and Tectonic.
That's correct.
So this is handling all 3 of those.
This is, and you know, Unity has these pre-designed platforms where people can plug and play elements such as garages, screen porches, master bedrooms, and kind of customize that through those configurations. Open Home is just a higher level in terms of passive house, getting to a higher standard of building and more flexibility with the customization. And Tectonics is really for the other professionals, architects, engineers that want a extremely fast but full quality build, knows what they're getting, there's a bit of guarantee, quality guarantee there, and can get it up fast on the site. And so they can come to us if they're using kind of our building blocks.
Right, basically the parameters in which these systems are built on, but maybe more customized by an outside architect and outside engineer. Yeah. Great. I don't even know where to start,
okay.
So let's head in.
Let's start where we start every morning.
Cool.
So every morning we start here right at this board. Almost everything we have is digitized, but this is what we don't. We've got about 30 to 35 people here every single morning, and we call this our Q-dip. And our Q-dip represents the safety, quality, delivery, inventory, and productivity. And it's color-coded, but that's not what's precise here. It's really to give everybody a voice, what has happened on the shop floor the day before, and it kind of takes a little of the emotion out of the, you know, what's happening in each person's daily lives. But it's to be able to report on any of that, either information coming in or information going out. Okay. And so the other thing we've got up here, which you don't see in typical construction, is really these. This is the project we have on the shop floor right now, and they're just these simple geometric shapes, and it might not seem like much, but what we're doing here is we're virtually bundling everything.
Right, I see, yeah, and you're seeing almost every component separately. So you know, you kind of understand what pieces have to be made and
correct.
What is being made.
And also, you know, you see the different colors, and that's the sequence in which it will be raised, and it's color-coded in that form too. So you can't see it, but that says Wall 01, Wall 02, Wall 03, and that's actually the sequence how the building will go up. It's also, more importantly, the batch size of how we process our information here. We're big into lean and making sure we can have turnover quickly. If we need to stuff another bundle in, say we have a walkout wall on a different job, we haven't measured for it, we can quickly get that bundle in. And so we can also load trucks from this too, all virtually, to make sure that these go on trucks. These are the first 2 wall bundles, but this goes from walls to interior walls, to floor systems, to our roof panels. And so this will be an insulated, completed shell in about 2 weeks, and we will blower door test it immediately after. And most all of our blower door tests are under 0.6, which is passive house. Right. They're not all passive houses, but we really pride ourselves on the air tightness of every single one of our builds, and we get it right after that construction. And that's something that people wait typically a lot longer for.
They're relying on whether it's wallboard or drywall and things like that to create additional air tightness. When you talk about lean, how has that process been formalized in a scenario like this?
Well, it takes a lot of buy-in from all of our associates here, and it's happened over time, right? We started in a very small facility. The changeover of going from walls to roof to floors, we were doing it all on one line at one time.
Yeah.
You have to get into that mode of, we can't just break for 2 days and reset and get everything going. But even in the early days, we were standing up wall panels. Then we were picking them up again and putting them over here and then doing it again. And it's like, what are we doing?
Yeah.
So a lot of it came from our own, you know, organic process and studying it, right?
Yeah.
I'm big into studying it on my own, and there's different ways of it, but we've even brought it to the, you know, the virtual world too.
Right.
Is, I said batch sizes, so each bundle is a batch size, and that's like half a day's worth of work. And so it also is how we export machine files. So if we have a screw up on a machine file, we might see it when we're dimensioning the drawings, and we said, oh, man, we might have that on those 12 other bundles. I better make sure I correct that.
Right.
Rather than getting to the last one you've exported and then say, oh, I screwed up, and going all back to number one, right?
It's funny, you
process.
You talk about studying it, and I've seen it done in smaller shops where they'll just set a GoPro and they'll take a photo every minute and they'll see how many times they touch something. And you know, a woodwork on Instagram had, they were measuring their shop or studying their shop, and they realized that everyone kept walking through like a trash barrel that was over there. They're like, why don't we put a trash barrel here?
Exactly.
And it's simple things.
Easy as that, right?
Right, and it's like those simple things that you study and understand, like how do we make this process, you know, especially, how many homes are you guys building a year?
Well, right now we're probably only in the 50 region, but it's not houses.
Yeah.
It's projects. That could be a 25 unit condo, and that could be a, you know, souped up garage.
Yeah, exactly, you know. Right. We walked by this. Do you guys do a mock-up like this on every project?
No, this is kind of just one of our standards for Unity.
Okay.
And so, but we use a similar wall system on Bensonwood too, but this is kind of, if you could imagine that, not being fiberboard, but a foundation. Yep. This is how we start up, and it's a great, and I'm glad you pointed me to this. This is a lot easier to see. So our wall system comprises of a bit of a modified balloon frame, if you will, because you can see the insulation running through here, and the floor system not platform frame.
So this is essentially an I-joist that you would typically see in a floor system or maybe a roof system, stood vertically and using it for that outside cavity.
Exactly.
This is where you're getting most of your insulation value.
Correct, and then we only have that, you know, 3/8 fin. That's the thermal bridge.
Right. Exactly.
Very tiny, but makes it easy to build, and you can see from the bottom up here. So let me just explain this too. We have a interior wall chase that's a 2x3 layer, and what we don't have showing here, but you'll see it through the facility, we have notches out. So Romex on site, the guys can run it. They don't have to drill holes through all of our wall systems. And then we have our interior vapor control layer. And then of course we're using, in this system, we're using the zip system on the exterior. And we're tying all this together with a PT bottom plate. And traditional panel builders, even back to SIPs, always ran the skins down further and put a shoe at the bottom, and you slipped it over. So you could use the J-bolts. What we're doing is actually fastening this really well and using this as our hold down inside this layer.
So this really, you know, I guess we'll call it our service cavity, which is thought to basically prevent you from damaging this cavity.
Exactly.
And so all your electrical, plumbing, but you're also using it from a structural perspective. So with that plywood that basically ties everything together, you can now fasten this.
That's right.
Again, now you're not relying on or damaging your
right. And there's you've got all that exactly right. And there's a few other things too. Is we can go onto the site and the concrete's sitting there, and we can go right into snapping line. We're not drilling PT. We're not putting it down.
Right.
We can go right into movement of the crane with snapping lines and going right here, and we can just put a couple Titan screws in the concrete. Just very so often get it up and deal with all that later. So we're using the efficient use of the crane.
You can continue to go vertical and come back and do your permanent connection.
Right. And you said this interior barrier here. We're also putting hold downs here. So we've designed hold downs that actually we can go in and screw those. So it's again the thermal conductivity. We're keeping it all into the warm side of the home rather than putting it out here where it might be developing some moisture, condensation, all that metal there. So we try to keep either our metals on the outside or the inside.
Sure.
And so you can see the same thing here. We don't have them here, but this is where we would actually screw in these walls and make the whole connection right here.
So this being your balloon frame,
Yep.
and you know, rather than this just relying on an anchor point here, you also have this as a bearing point.
Correct. And the reason we're using the 7/16 sheathing is it's really robust as carrying these walls down the road, putting them up on site, weatherproofing in the short period of time that they are out in the weather.
Yeah.
And that's actually our shear layer. The other thing is, though, it's something that somebody's not going to just come in and hack their knife with and throw a penetration through without really thinking about it.
And that's something that we deal with on site, where, you know, we actively avoid spray foam for a number of reasons. And oftentimes we're using like a mineral bat, and then, you know, we're trying, if we have the opportunity, we're adding insulation on the outside so we don't have to deal with vapor retarder on the inside. But that's not always the case. We have a home now that is more traditionally designed and just didn't have that forethought into building something with exterior insulation. So we have to have that vapor control layer on the inside, but it's a membrane.
Yeah.
And, you know, the biggest concern is like, yeah, we'll spend an enormous amount of time making sure it's perfect, but the moment someone else comes in there, opens the wall, renovates, it's, you know, we're potentially damaging that to, you know, unsafe.
What we go to the extent in our virtual fabrication is to really put in every single sleeve, whether it be an outdoor receptacle, an outdoor sconce, our air handler, all the penetrations. We either box all those out or put a PVC sleeve that you can tape up in foam that's prepped, and nobody's messing with the insulation at all.
This is what I really appreciate about panelization and, you know, building this stuff in a controlled environment. All of this is great, but it's all of the planning and the forethought, where it's like, you know, we talk about cost constantly. We talk about like, this is more expensive. It's like, but when you really think about it and the amount of time that you spend, those are the things that start offsetting the cost, where it's like all the gray area. It's like, well, who's drilling the hole through for the condenser?
Right. You're getting like, the subs arguing on site. You're getting the change orders.
It's, you know, and even things like, you know, even things like notching for the service cavity, you know.
And we don't get a kickback for that.
Absolutely, there's no way you would. It's like you're making someone's job easier, and frankly, the time it takes to do it here in a factory is, I have to guess, less than 50% of the time it would take to go on site and drill through everyone.
I would agree. And it's being done by a machine.
Right. And it's cleaner, it's keeping the job site clean, everything is just is beneficial. And going back to something you said earlier, you're getting under 0.6 for ACH. You know, these are some of your detailing here for air sealing.
And so we're always trying to keep that to the interior of our wall, and we're using the tapes on the exterior. So anywhere we're going panel to panel in either gravity or mechanical fastening, we're trying to keep this to the most inside region of the assembly, whether it be the roof, the wall, the floor.
You're saying this here.
The gasket.
Why is that?
That's because this is our interior vapor control layer, and we want to make sure that line, you know, that is not, no heat is getting through.
Gotcha. So you don't want that vapor basically coming all the way to here and stopping and then having basically go back. So this is just, when is this installed?
This is only installed on site.
Right. So that wall goes up and they come by. So
we air seal every panel itself in here really well.
Yeah.
And then that's all the on-site, and that goes to the, you know, all the months out of the year, whether we're building in Colorado or.
Well, I was just going to say that this is, rather than using an adhesive or a caulking, you know, if it's freezing up, this is just a pre-manufactured rubber bubble seal.
Right, and we can put it down on anything, right? And it's getting that air seal, and it's very quick too. You don't have someone with a glue gun or spraying foam.
Sure.
You're just laying this down. We're stapling it typically to the wood, and we're putting the panels together.
Yeah, you're stapling it right through that membrane here.
Yeah. It's so quick. Now the other options we've got here at Benson Wood have a lot to do with a different, like you were saying, an exterior insulation. So we like to use wood fiber products, and that's what we're using. And we might have one actually, a piece right here, just to show. But you know, we have a piece of wood fiber board that's tongue and groove. This is an 1.9/16", and it's about an R5. So, you know, with the addition of something like this over a 9.5, we can get to passive house levels pretty quickly. You know, obviously this all depends on our region of climate and things like that.
But, and the client's expectations and desires.
Exactly. And it might you know, we might want to be almost a passive house, but I don't want the certification, but I want to be somewhat economical.
Right.
There's all those factors, of course, but
Yeah.
that gets us to a continuous installation pretty quickly with very little thermal bridging in the I-joist.
What I like about this mock-up, and then I want to walk around because there's a lot to see, but it really gives you an understanding of how this would get erected, where this wall, if you can kind of look at this section by itself, is going to stand up, say, on your concrete slab. Obviously, you have the seal. And then you can see that gets stapled, and then this wall section can go up, or this floor section can get set.
It's actually the floor.
The floor
right?
will go.
And it's
go
kind of
next.
like that safety, like,
yeah.
So this floor, you'd be amazed, you know, depending how big, of course, goes up in
Seconds.
so quick.
Right.
And what's sweet about it is you're not stringing all these walls. First of all, we're using these glue lam for top and bottom plates, so you're not going nutso with stringing walls, putting braces everywhere.
Yep.
We can put one in the middle of a 36-foot wall and it's fine. But this goes on and it kind of locks it all together because it's actually inside.
Well, that's what I was going to say, is you have this like shelf detail where you're connecting not only from gravity but also here, and that's pulling that wall tight to the floor system. That next wall slides right against the floor system, but you also notice it up here where this roof set system comes in as a piece and essentially sits on your top plate, and then you have your plywood running up another 4 inches to basically stop that, and everything locks together. If you've ever seen one of their installation videos on YouTube, you should check. If you haven't, you should check it out because it's really interesting. That you guys have great time lapses of the homes going together.
Not enough of them, probably.
It's probably not.
But what's real interesting here is it's a testament also to the accuracy of these guys in the shop, because we actually draw in a 16th at either end, you know, just for a buffer. Everything has some kind of buffer. This is actually an 1/8 in terms of the world. Same with there, and it actually kind of works out with wood and concrete and everything. But the floors are only a 16th end to end.
Yeah.
So it makes it so precise. It's pretty amazing. As long as that layout's good, and you must know exactly how this is, and it can go sideways quick if you don't get this layout right. So it's pretty amazing to get these buildings up. So, you know, we come back, talk about the lean process. We come back and the guys are like, well, this didn't go good. We had a pre-drill wrong. And it's like, yes. And we are considering that and we're figuring that out. But if you step back a minute and say, wow, this just happened, just, you know, it's just amazing. And so on our way, you know, we talked about lean and you talked about the trash being, you know, here or there. Well, it's another thing, right? We've got these little satellite stations we'll see around the building, and this is the hub for all of our tapes, our foams, our nails, and a person once a day goes and fills those satellite stations. So we have 20 satellite stations. It's just what you need for the day, basically. Instead of someone walking a quarter mile coming to get a handful of screws, each station has its little hub.
Gotcha.
And so we were just talking about the Nordic lam, and so here's the difference, right, from buying SPF lumber from a lumber yard.
Sure.
Right, we've got this in 36-foot length.
Yep.
And this is all glue lam. This is black spruce. And we've got this in the same materials as any other structural component. We stock actually 2x6, 2x8, and then we go right up to the 9.5 with I-joists and glue lam, 11 7/8. And 14s and 16s. And you can see above us here, this is our vacuum lift. And hopefully we'll get to see this operating after the comes back from break.
I've seen it for plywood. I've not seen it for framing lumber. So that basically, I mean, I think it's self-explanatory. It lifts that lumber up. But unlike, I think, the panel or the plywood ones, typically you need to have that whole surface area of the suction cup on the panel. Here it looks like it basically uses whatever it needs.
We can basically take the whole top layer off of every unit. It can self-feed itself at night. So if we're low in inventory, we just put a stack over there, put it back in. But the real use of the machine is bringing the layers from what we need in our cut file to our speed cut machine over here.
Gotcha. So everything gets self-fed here, organized by size. And then here's our cut machine.
Yeah. And so this is the SC3. We've got an SC1 beyond. We typically use that just for SPF lumber, more 16-foot kind of stock, interior walls, things like this. And just because we have all of our 36-foot long stock right in this staging area.
So glue lam is going to be used for top and bottom plates because we want those walls to be straight.
Correct.
You know, and you're going to be infilling for your, for lack of a better term, studs with an eye joist, which is also going to be straight. But that service cavity can be an SPF because you got a nice straight wall, and now we're using just a 2x3, and obviously you want that to be straight, but it's not as important to be an engineered piece of lumber because we already have our nice straight wall, and we're just adding a cavity to
exactly
for electrical and so on.
And like you said, with the 9.5 being an engineered lumber, you know, if that's SPF, if it's a 2x10, and we're going through these accurate machines, you can imagine the twisting and everything that happens.
Right.
So while some of the engineered lumber is a little more expensive nowadays, what it is it's very straight.
Right.
The machines like it.
Yeah.
It nails it square. We can put our plywood on. There's less twisting. And really, a lot of the quality of the lumber is going down nowadays. So you guys saw that simple geometric shapes on that bundling paper, right? So here's a little bit more on, so this, if we were to look at this wall, or I'm sorry, this home fully elaborated, this is where we get into the nitty-gritty details of, so if I were just to take this wall. So if I start picking apart this wall, you'll see eye joists, you'll see Nordic, but each part has its own attributes. So it's 9.5, it's always orange, it's an eye joist. The production number is that, so the guys know how to read it off the plan. It's 2.5 by 9.5, it's 2 foot 9 5/8 long. It's got all these attributes, and then it tells us, okay, it's module 1, that's building the RO components. It's Nordic, so that we have the manufacturer, we have the series of beam, NI40, it's framing, it's part of W08. So there's all this embedded attributes, and this machine's cutting everything on that, printing it on there, doing any other cuts, shaping, drilling. But really, those simple geometric shapes was just this block version, and what we have is this bit of like an algorithm almost. It's called an element routine, and it knows, okay, with this window here, I need to put jack studs.
So that's going to be automatically made.
That's automatically. It runs a routine on the surface of the wall, and it says, I've got the pad out layer, I've got the sheathing, the exterior sheathing, each of these studs. Here's what the ends look like, depending if it's a gable or an eave. So all those attributes are also given to this panel to say, how does it fill out the studs?
So that software, is that something that you guys developed, or
this is actually a Swiss-based product, CADwork, and we've been with them since the late 90s. And we actually had, I think, one of the second Hundiggers here, and you'll see that in the other shop. We're still using it to four-side plane. Yeah. And we got that in the late 90s, and we're still using Hundiggers strong, and we've been running the software, CADwork, which just matches up well with it.
And is this software strictly for this, or for the entire home?
The entire home.
Okay. So plywood.
So design, they'll use Revit a lot.
Yep.
But when it gets to the nuts and bolts of this thing, you know, this is the software we're using. And so if I were just to bring up all the walls on this project, you can actually see the engineered wall straps all drawn in there.
And those components,
the hold downs to each and every screw. So it's pretty wild.
So a lot of this, when we talk about like these hold downs, like as code changes, you know, and maybe there's like a code requirement that, you know, says now you need to have two hold downs, that can be changed kind of at the base of the program, right?
Definitely.
And now anytime you have a new home being uploaded, again, going back to the algorithm, it's going to say, yes, this wall now requires 2.
Right.
Exactly. Or that particular hold down isn't manufactured anymore, and here's the new one.
Yeah, exactly.
That's interesting. I'm looking at this as like, wow, there's a lot of components that you have to draw and design, but...
And you can see, so this is a tight shear wall with a door opening real close, and you have it on both sides, but you also have the Titans we were talking about earlier, all drawn in there. This is actually a sleeve penetration going through for exterior receptacle. You can see a few more here, along with some hold down straps from the interior.
Right.
So everything, the story's told right here on this computer, and actually all of our carpenters know how to navigate this program.
Yeah.
So it's pretty cool to be a carpenter and then come in and learn some, not necessarily we're drafting, but we're knowing how to navigate, we're knowing what to look for, how to use this computer on site as a tool.
You know, someone that's just cutting lumber all day, it's like, it's just lumber that's being cut. But when you understand what the bigger picture is, like, oh, these are being cut for that.
Right.
And it's when we render spaces, we hang these renderings up in this, you know, in this space, because we want everyone to understand, like, what is our end goal?
Right.
Like, what the work that you're doing right now, what is that going to eventually turn into? And when you have that bigger picture and have the opportunity to understand what that bigger picture is, it typically, for us, makes it
and
more
everybody
successful.
with the same transparency, right?
Right.
Just that visual. It's a huge bonus, and you can't even put money on that.
Yeah.
Everybody should know, right?
A lot of time is spent in the design here, but it pays off, you know, throughout the entire process. Even talking about like the holes for the receptacles or that light next to the door.
Totally. Well, we think so.
Yeah.
Because, and you probably know more on your side of general contracting on the site, all the provisions that are forgot about sometimes.
Well, we know it's right.
Yeah.
Where it's like, why is that light at 6 feet? It's supposed to be at 7 feet. It's like, oh, you know, I didn't know.
Yeah.
Is he gonna turn this thing on?
Are you cutting anything?
You're in my way.
Come on, just butt me out of the way here.
This is gonna be a service cavity wall, right?
So yeah, we've got a service cavity going on here, but we've got a large saw, series of drillings, a revolving mill, an end mill, and then there's a pre-drill back there. And so, you know, when we're doing like those floor systems you saw with the rim and it's gonna get fastened to the bottom and top plate, we'll actually pre-drill that rim. So these guys in the shop are actually putting 2 4.5 inch
Pre-drill with
screw.
like an 1/8 inch drill bit.
Yeah. Actually, it's 3/16, but yeah, exactly. And so it just takes away some of the thinking. You know, he doesn't have to pull out a measuring tape. It's already there. We tap a screw in. It's already there. We don't have to go to the job box to try to find the screws.
Right.
With the million other things we have for fasteners out there. So, and you're not always thinking about that, but that is how we think about having all this stuff done ahead of time. These guys out in the shop on their shop drawings, that whole pre-drill is labeled as the screw. So it'll automatically come up on the shop drawing, 4.5 inch SDS screw. And so they already know what's happening there. So you can see the large saw in the cavity, it just spun around.
Yep.
And it's got a measuring tool on it, and it makes a dust cut. And like you said, this is the interior pack out layer for the wall. And so I think it might have just done some inkjet printing on it. And here's the revolver mill. Not exactly sure what it's doing, but oh, this is just a bottom or a top plate, what that was. And that little it's just a V notch we're putting in there. And that's so the guys don't flip it upside down or do-si-do the panel. So you always know it's got a little indicator notch, both for here in the shop, but then on site again. Hey, we don't want to flip this wall around and put the RO in the wrong place for the door. Which you'll see.
Right here, yeah. Oh, so this is all being printed on the machine.
Yeah, and this is, like I said, it's a plate.
Yep.
So that's the indicator. This is all layout for the studs, already on there. And this will actually go through another machine over there that will automatically nail this together. And we'll see that a little later.
This is cool. I don't even know what my reaction was going to be to that, but that's cool.
So this is panel A02. This is the number. It's a bottom plate.
Yep.
And module 02 is because this is actually must be some kind of assembly for an RO. That's what we call modules, and that's like a more specific part of the panel than the larger panel itself.
Gotcha. So when you said we're going to see it in a little bit, but this plate will go over to another automatically nail. Everything gets spaced out automatically.
Yeah.
So no one's really ever touching that.
Well, a little bit.
A little bit.
I mean, you can see behind us, we're putting it into our different panels that are labeled, and each volume here is a bundle.
Okay.
So he's prepping bundles ahead of time.
Right.
And it's just in time. So he's not only feeding the wall shop, he's feeding the roof shop, he's feeding the floor shop.
Right.
So he's kind of like our quarterback, and he's like, okay, I got this bundle. Now these guys need work. These guys need work. So it's pretty cool what he can do. But Brett, with so many years out in the field also, he knows what he's looking for. He knows the models. if there might be some feedback, he knows it already, which is, again, you're not just gonna pull someone into using this CNC machine and turn them into a carpenter. We're turning a carpenter and turning them and training them to do the CNC.
Right.
So yeah, you can see, so this is actually when we have a floor system above a window and it's resting on that pack out layer. We've still got the header in the wall, but we're putting screws through this to carry that load of that joist above.
So that
makes sense?
Yeah, this will go, this service cavity being bolted to your header that's in the actual outside panel.
Right above the window. So
this is just, that's your 3/16,
yeah.
And then you put in a 4-inch or probably a 6-inch
Yeah, it's
screw.
probably a 6-inch one on that one. Yeah, exactly. So this is something I actually show people just because I think it's real easy to think about. You know, we have our own engineered joints here. So if you could picture this being an outdoor framed roof system. Yeah. So we're just making a mortise and tenon joint there that's engineered. And what it does for us is, one, the guys don't have to pull out a tape measure to get their 2 foot on center.
Yep.
They're just putting 4 nails in it, getting it done. We're not procuring a hanger. Mm-hmm. We're not trying to find that hanger, either on site or in the shop.
Sure.
And so it's quick and easy to set up these standard details like this for us to continue on always using something that's going to benefit us in the long run.
All right, so this is my opinion on this stuff, and I'm curious at what your thought. This is why I like CNC and just computer control in general. Yes, someone could sit there and hand chisel that and have that handwork, but that right there is a perfect example of how you were able to take technology and be more creative with it for a better end result. Because to hand do that would have been, while it's great craftsmanship and you can't get away from that, but doing that 20 times over, no one wants to do that. And frankly, they're just going to say, you know what, just get a hanger for it.
Exactly.
And the hanger's not going to be the right roof pitch, but it doesn't matter, it'll hold the roof up.
Yeah.
And that's the separation. That's why I'm such a big, supporter of technology and panelization in general, is that you oftentimes find more creative solutions.
Yeah. And then you get to keep evolving, right? You get into the more specific and say, oh, I want to create more.
Right.
I want to understand how to do this better. And your focus might not be on that banging of that nail anymore.
Right.
It might be on, wow, I can really use my head to come up with bigger and better ways for everybody.
You do that, and it's like, all right, what else can I make that machine do?
And you can see, Brett made this for me, and it's just this thing we've always showed, but he made this
That's
himself
all on the machine.
And you can see the tenon up there, and then there's the revolver mill, the bird's mouth, the end mill making a tenon, another one of those joints, a couple pre-drills on both edges, layout.
Imagine doing this by hand.
Yeah, or just, I mean, I know that's an easy cut in the valley to be doing something that, or a hip, but I mean, that's a lot of layout right there. And I'll tell you what, drawing it is very easy.
Right.
With things intercolliding, you're just cutting away. Right. But to lay that out is super complicated.
Right. You're referencing the edge of the wood. On a computer, you can snap lines. Yeah.
And so we really try to pride ourselves too on the roofs, especially. Let's put all the complication we can right here at this height. Yeah. And build all that here, even in the rake overhangs, and think when you're thinking about hanging over roofs.
Right.
And do that here while it's at waist level rather than on site. Yeah. So we try to do that.
So we're gonna come back to the center section here?
Yeah.
All right, cool.
You gotta come back around.
Just making sure we're not missing anything. We saw zip being used over in that mock-up. Is that something that you guys are adamant on for your system, or are you guys open to using, say, like a siga product or another WRB? Yeah,
we actually do use siga. We use a lot of siga actually, and we use it over our WFB wall, our wood fiber board wall. We do a lot of our taped openings with it. We do a lot of our concrete taping, but that's something in the industry that was developed, and it's pretty easy to use, and it kind of protects our product as it's getting built. And so other than the wood fiber board wall, that's typically what we're using is the zip.
Cool.
So what we have here is the start of the roof line, and these aren't going in those special trays that I showed you over there with Brett, but this is getting forklift over by bundle with all the rafters. And what we're doing here, we don't have the greatest panels to show you here, but we're starting up. But you can see how this works. Basically, so Jason's pulling over the rafters that he needs. Oh, sorry, Josh. He's a twin here. I looked up, I thought it was Jason.
He had a smile like you were wrong about something.
He knew I was wrong. I'm always wrong. This guy's always wrong.
I'm with you, man.
But this, you can see this is going to be a 2-foot on center panel.
Okay.
And what we do with our roofs is a bit of a shiplap detail. So the sheathing hangs over on one side and it's held back on the other.
Okay.
So we start in the middle. We actually hold back our middle panel on the I-joist, and then each panel subsequently flips on top of it.
Let me back up for a minute. Where did these get cut?
So these were all on that speed cut.
Oh, they were on the speed cut as well. So all the overhangs, everything was pre-cut.
Yeah.
And then I see the infill with Advantech. Is that also cut on that machine?
Yeah. So a lot of people just stack a vertical for the load transfer from the web to the web and down to the wall. We just stuff it at the end with our scraps, and then the machine can make it exact, and we have a stiffer overhang as well.
So who's putting that, how is this piece of plywood making its way into the web?
So Brett's pre-stuffing it. He knows where it's gonna go. He cuts off this end first. Okay. And he just puts some strategic screws in there, it comes out, and then he staples it all off on the outer edge.
So I'm guessing here, but you probably have all your scraps being ripped to a particular width.
Exactly.
So then when you know that you're going to be stuffing the ends of these rafters, he's tossing them in, it gets cut into it, and like you said, it gets stapled off.
That's right.
Gotcha.
And so you can see these guys go with their bigger bundle list here.
Yep.
And we're using this Nordic because either we're going to be framing a rake overhang here, or something like that. But this is all 2-foot on center. It exactly lines up with all of our studs. That's traditionally what we do.
Yeah, stack framing, advanced all framing. The way up. Yep.
And what you'll see, we're not going to be able to see it with these triangles as well because we've got a lot of valley panels and overlay panels. But what we would do here next, so he would frame this a lot like a floor system. We put the subfascia here, and he's putting on a rim, what we call a rim up there. And that's the peak of the roof. This is the bottom of the roof. And so all we do right at this station is frame. And you can see he's got QR codes up there. I don't know where his tablet is.
The framing layer that I'm looking at.
Here.
So this is this panel. This one actually is 12 inches on center.
Oh, okay.
The rest of them are 24 on center, but I was going to look into it just because I was curious.
That's twice he's been wrong.
Yeah, twice in like less than 2 minutes.
So it's got all the part numbers for every piece of blocking, every stick.
And that's what's been already inkjet printed on there.
From NSC. It's color coded for materials too. So you got the purple, and that's the Nordic material there, and then the orange is the I-joist, and yellow is our
your rim. So the rim is since these are panels, you don't ever have a ridge really, unless it's probably.
No, that is the ridge. Oh, we have a ridge beam that's then, and I'll talk about that later. But that's at our other facility. So they're producing the timber component.
Yeah, it would be like a timber more aesthetic, but in a panel configuration, you have the two rim coming together.
Correct.
Yeah. And we do pleats down there.
So the other thing just to look at is on these shop drawings is the QR code. So he scans that, so he knows where the panel is. Speaking of the lean, right? Mm-hmm. How many lineal feet we're doing, how many square feet. He also has where it is. So this is that station. We scan that.
Gotcha.
And employee code over there.
And we've got the employee code that actually can fill in their time card for them. Yep. And it's not about tracking anybody. It's just about data.
Right.
Reoccurring data about we track. Although we price per square foot, we track lineal footage. Okay. And it's just an easier number for us to say, hey, the goals of the day, that back at the QDIP board to say, we need to beat budget 90 lineal feet today.
Yeah.
And so that's what we go. And then.
But like you said, you have all that data later on. So if you ever want to know who built the panel or when it was built.
Or what happened.
Right.
Yeah. So he's on that framing station. And so all the other ones are right here too. So we've got the sheathing. Yep. We've got actually just insulating if there's anything special to be in the insulation. And then, actually that was just the flip side sheathing. Yep. So, and it gives us all these notes of specific fastening, things like that. So all this is an automatic output from that CAD work drawing into 2D. So we're trying to keep as little paper as possible.
Yeah.
And
No, it
keep
makes
that
sense.
going.
The only
Thanks,
paper is
Josh.
the QC sheets.
Yeah.
Bundle sheets.
He wants me to get rid of those. But everything is, you know, there's a checklist too for quality control. And many jobs of ours are third-party verified.
Okay.
So we've got a full QC checklist. Panels can get stickered depending on what states, like you mentioned Rhode Island earlier.
Right.
That's one of those specific states.
I remember that being a conversation when we talked about that job.
Yeah.
And that they would need that third party.
Yeah. And so it holds us accountable too.
Sure.
If we see a screw up, we're reporting it the next day.
Yeah.
So here, I'm hoping you can envision this next panel, but these are the two panels they have now. What's happening here is this is a fence that can actually flip up either this side or the other side
And
to
create
keep a right angle.
Yep.
And so he'll be able to slide this fence in, get it square, and then they're able to use the vacuum lift here and bring all the zip sheathing onto it. And this is what we call our chicken boards. And we're actually putting all of our boards on the roof surface for them to walk on when we're on site. But also it's what they pick it from this crane. So that will have a series of 4 straps. It'll pick really well.
Yep.
And we'll flip it here after we're done sheathing. But what's even better is when we're on site with the chain fall, and we actually use it to pitch the roof panel so it actually sets in there real nicely.
Gotcha. So you're not trying to set down and let that drop in place. You're putting it in place.
So we're putting all the zip in, taping it all, really making this water resistant, and because we're injecting cellulose in all of this. So.
Right, and I assume that this here is probably an area that would be otherwise hard to insulate.
Yeah,
so
exactly.
You're doing it ahead of time.
So that's that shiplap joint that I was mentioning earlier. So that's the sheathing overlap, and these are going to just go butt to butt. We're going to tape the interior seam. We're doing this just like the wall. This will also get 7/16.
Yep.
And so we'll tape that inner area on the 7/16 to 7/16.
So this will get filled.
That will all get filled by this machine down here.
Gotcha.
Maybe, can we catch somebody down here? Might not be able to catch him. We're unwrapping cellulose and stacking it back up. You see that, right? Instead of getting a large bale.
Yeah.
And that is...
And that's plastic.
That's typical, right? That's typical in Europe. You're getting a large bale, but more off-site construction there. Yeah. So we have a hard time because everything we have around here, just like the lumber at the lumberyard, is made for the 1 or 2 person consumer.
Right.
Right. So everybody's loading these in their truck. They're blowing them from on the site. Right. We don't have any partners to partner up with here in the area that can say, okay, we're going to take this many bags. We take a lot of them. Yeah. But not to fill a whole plant that's making cellulose, right?
Fair enough, yeah.
So it's an interesting way to look at it.
But it would be interesting to see how that changes over the next 5, 10 years.
Yeah, and hopefully it does. So you can see a pretty, you can see a pretty complex panel here. So this has been flipped, it's been cellulosed. The sheathing's going on. I asked Greg to leave it off so he could just see.
So does everything get glued?
We glue the perimeter. And 1, because of air sealing, 2, because it's just common practice for these guys to say, okay, we're not going to glue this and glue that. We're going to glue everything on the perimeter. You know, that alleviates us to be thinking about walls that might get vertical rain coming down through ROs, whatever the case may be. Just glue the perimeter.
Yeah, because this panel may see water.
Yeah. And it may be upside down in the yard too. Right. Sometimes we flip them upside down if we're using roof boards. Yep. We'll do the first panel upside down. But these will all get taped with Reson, Siga Reson. This whole thing will get taped. And
so there's no concerns with this getting wet?
Nope. Right. But you can see, he hasn't cut all this off, but you can see a kind of a complex panel. Again, to be doing this all in the air, to be lugging around material this size in the air with 2 guys or 3 guys, it's just a ton of material to be putting up on a job site. Yeah. And that one also has the rake overhang all built into it as well. So there's just a lot going on with this panel. You know, you have the rake, you've got the bird's mouth and the eve cuts, you've got an overlap. There's a ton that's happening right here, and that's why I said earlier we're putting the complication in the panel. So that's the other thing, right? It swivels. He doesn't have to have a perfectly square panel. So you can change the up to 25. You can change the amount of fill that's going in and the amount of air in that mixture. So that's why I said recipes, because we can dial it in for different thicknesses, different length bays, different heights, because we have the same machine over in the wall shop and that's not as thick. So this is kind of interesting. I just want to stop here real quick. So this is a cleat that goes on here, which mates up with the timber frame that we'll be doing in Walpole. So if you can imagine the timber frame and it has this notch out, this actually hangs in there. So this locates
they'll
the panel.
set the beam.
We'll set the beam.
Walls will be up. They'll set the timber frame beam. This roof panel will come down and sit.
Lock right in. And so that'll give us a positive stop. We're not wrestling this large 3,000 pound panel up in the air. But the other reason we use it is a lot of times we're pre-boarding this panel. So each section will snap lines every fourth board and we'll fold in tongue and groove boards, and that will be your ceiling finish. And the way we do it without wiring the whole cavity is we actually keep them back here, 1 to air seal, 2 to run Romex and things. And what we'll do is we have our mill workshop will make like a faux beam, like a batten strip.
Yep.
And we'll make these termination blocks. And so we'll be able to run our ceiling fans or LEDs off of that, or hanging pendants, whatever we want out of that. So it's a bit of a system.
Right. And then you use all the
and that'll help us. That helps us line up. You know, depending on, like right now it's real humid, we'd be nailing those boards together, and you know, 3 days from now it could be real dry, and those boards would be shrunk 3/4 of an inch. So that's why we snap the line every fourth board and fold them in. And this just locates them so you'll see dead nuts down the whole parallel length of the building.
Any project that you're building, whether it's on the tectonic side or even the unity and everything in between, it has to be fully designed. Everything has to be done. Electrical has to be figured out. Like they're really, you're not saving anything. You're probably spending more money doing it this way if it's not fully baked.
Right. Yes. And that's a hard thing for
a lot of people.
Some people to consider, because they think they're going to walk around the house while it's still got the bones there, and well, I might want to move this wall.
And that's an argument that, you know, I've had, and we've talked about even on the podcast. It's like, well, what about the whole, like, you know, what about walking around and figuring out where you want things in the moment? It's like, well, a lot of that, you can be 100% figured out and then build it, and then when you are on site and you want to change something, you still can. It's just more difficult. But the whole point in thinking this stuff through, and this is what we talk about all the time on our channel and with our clients, is let's figure everything out. Yes, you can absolutely change things, but if we spend the time now to figure it out, at least we have the end goal and we're all working towards that. And when you're making these small changes, you don't like that window anymore, or it looks at something that you didn't realize it had a view of and you want to shift it, yeah, it can be changed. But the reality is 9 times out of 10 or 9.5 times out of 10, you're not gonna want to move it because it's already been thought through.
So you can see over here that we're gonna go backwards just on this is our open cavity area, and we're doing floor systems right now, but this might be actually site construction stairs. We actually make our own construction stairs just so we can plop them in with the crane in the raising too, so people aren't going up and down ladders. So over here you can see the large format panels that are, you know, it says it right on them, and it's in reverse order. I know that's obvious, but when you're building large material, you don't want to be, like you said earlier, picking them up, putting them down. So we're building FL11 first, FL10 next, FL9 next. And so
that way, as you're picking them, it's 1, 2, 3, 4, 5,
And it seems so obvious, but you can spend a lot of time moving large things around.
And not only is it inefficient, but it's also it's also risking more damage. So is this inch?
That's 7/8. So we use all 7/8 at Vantech.
I was gonna say, we use 1 1/8, and it looks slightly smaller.
So we do that a lot of times. Let's move over here. And but yeah, we're using 7/8 mostly on all of our buildings. And you can see the clean cuts though, and how straight those lines are down there for that many pieces of plywood. Because it's the same as I was telling you with the roof. It's a shiplap detail. So where you know, on typical sites, you're seeing people hammer T&G down, putting the block down, taking the sledge, and that's how they're squaring up. They're relying actually on
the plywood.
The plywood being
Right.
square.
Yeah.
And where we're setting an edge, we're actually snapping a line down, and we're setting that edge. If this means that opens up a little bit, doesn't matter.
Right.
That's straight. We know what straight is. That's straight, and this is
your
straight.
reference point is 90 degrees.
So it's a
pull
little bit
everything.
of different concept of thinking.
So
But
you're
this
not
is-
as worried about overlapping your floor
Right.
seams because you have this shiplap detail.
Exactly.
Yeah.
So everything we're doing here is frame sheath, frame sheath. This could be exterior roof.
Yep.
Like I said, it could be the stair systems or anything. But you can see behind Zach there, I just want to mention, those are the satellite carts with the amount of screws that they're filling. There's one of those at each station.
So someone fills those and delivers it to that station in preparation to build this.
Correct.
Yeah.
And we just want a day or two supply there. We don't want an overabundance because then we just have overstock of material.
So what do we have here?
So this is just a ceiling.
So that's
it's just open cavity ceiling. We're not even sheathing this, I bet.
So this is just a standard SPF, you
Yeah.
know.
Ceiling, it'll get sheetrock underneath it.
So not as important to be.
Not as important, but you can see they've got the pre-drilled screws. They got the screws already started. So that'll ship right there.
And has this been printed too? Or is that?
That's printed off the machine too.
So why is that red?
He just has these, what are those, the NASA pens that are in there. It just has different colors.
Oh, okay. Same. Oh, ceiling right here. That's how.
And I don't know if you've noticed also the carts, we all each have the same cart, and it all has its battery drills, its pneumatic tools, and it has actually a smaller subset of screws also. So we have those that are just wheel around. They got all the tools they need on every single position throughout the shop. Hey, Jason.
That's the other twin, right?
Yeah. Wall framing. So we're starting all the walls here. We missed out, it looks like, on a wall, but we'll show it a little bit later. But what we're essentially doing here is we've got plates over here.
Yep. So that's your glue lam.
Yep. And then we'd have wall studs over here. And what Matt's doing is he's building modules. Now he's only on the strapping layer right now, or the interior furring layer. So he's building like a window RO for the next component he'll be nailing up. And it looks like he's maybe a little behind. Usually we're way ahead on this station, so we only man it with one person. But basically what happens is a bottom and top plate come into this machine, and this gripper wagon grabs the bottom and the top plate. And it's got a gripper wagon on both sides. And this moves in and out all the way up to 10.6.5.
Yep.
So we can build anything from like 4 foot to 10.6.5 on this, as long as it's rectangular. Right.
So if you're ever dealing with a 2-story wall, you're building that in sections.
Yes, because we're also shipping these over the road vertically, because we're installing all the windows.
Yeah, and 10.6 is wide. I mean, you're
I'm
wide load
over
at that
height,
point. Yeah.
kind of on a step deck already. 10.6 is the max with the bundling bunks. What we've got is that gripper wagon comes in, and it automatically starts extruding, and these nail guns come in depending on if it's an eye joist, it just fires bam, 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 bam. If it's an eye, it gives it 2 down low,
I
2
got
up
you.
high.
So you're pulling that wall, and it's dropping a stud, nailing it, pulling it, dropping it. Gotcha.
Exactly. So it will call for either a module, which he'll be rolling down here, which will be a whole RO assembly, or a common stud.
I see what you're saying. So that right there, just to make sure I understood it right, he's creating the window opening, and that will go in as a module, but anything as like a common stud is being fed and automatically placed and nailed, and then when it calls for that module, it's going to pull that module in,
right?
And there's your window. I got you.
And you can see right here, this is all millimeters, but these guys know it's almost like reading code in here, but it's also an export from our CAD software.
Why millimeters?
Well, because it's all European machine.
Okay. That's a good answer.
Same over there.
Okay. I think we should be I don't know why we work in
it's so much easier.
Feet, but I can't get everyone to
so
switch,
he knows exactly how to read this, and so when this is coming through, he knows which part, and it calls for it. Here's the stick, here's the module. But this thing goes so fast, I mean, you'd be amazed at how many lineal feet per minute could go through this if you're just not having to do any of the prep.
So what's the goal for linear feet on a machine like this for the day?
We have a goal overall.
Collectively.
So, and it's all based on budget plus 10%.
Okay. fair
That's
enough.
what it is.
Yeah.
You know, we don't try to, because we want to focus on quality too, not
Right.
just.
Well, that's a good buffer
productivity.
where it's like, you know, if you're hitting budget, you're in budget.
Right.
If you're hitting budget plus 10, then you're more profitable.
Exactly.
Right.
Exactly. So this is a panel that Matt just framed, and it came down on the belts and is ready to go for these guys for sheathing. So they're checking on their plans. Behind us, this is the interior of the wall.
Okay.
And then Matt's framing the interior strapping of the wall next.
Right.
And so when this gets sheathed and taped, we'll just be shoveling this on top, and over on that station over here, we're nailing that strapping off to this wall.
Gotcha.
So for here
And
though,
then it gets flipped
correct.
and then stuffed and then
Yep.
the interior sheeting.
Exactly.
So window,
Window.
what is it? This down
So
here?
that is the back side of the window that we don't want to fill, because when we flip it,
Gotcha.
we'll be filling it with insulation, and what we're doing is it's just a giant box beam. So we
Right.
get no thermal bridging through the whole thing.
Right.
So we don't
Rather
have
than a
studs.
solid piece of wood, you have single layer stuffed with insulation, second layer on the back side.
Exactly.
So that just temporarily stays there until it flips over.
Right.
Gotcha.
And so you can see all that goes into this though. Like, so you see here, this is definitely a penetration for air handler or something going through the wall.
Okay.
So either an intake or an exhaust. And the reason I know that is because it's filled with insulation. It's a big cutout.
Gotcha.
We wouldn't have normally extra studs here.
Gotcha.
And that's another kind of penetration over
so
there.
they're just putting in, this is like a foam product.
Yeah.
Yeah.
And that'll all get foamed up later, spray foam.
Gotcha.
Just because that's the easiest. You know,
Right.
and what we'll do is we'll route out this so they know where it is in the cavity.
Yep.
We won't do the exterior layer.
Gotcha.
So it'll be coming from in to out. They'll lay out that inside of the
Yeah.
wall sheathing.
Yeah, say it's an ERV exhaust
Right,
or something
exactly.
like that. Okay.
And so what's happening here is the 7/16, we've got a squaring jig here on this end, the 7/16 comes on, and this machine is our bridge that comes off and automatically nails everything off. So the whole perimeter gets nailed off. Even if it's a shear wall, it can go down to 4 inches on center nailing. So that's, again, all in the program, how we draw it.
Right.
And then it goes around and does 4-sided routing and then routes every single RO too. So a lot of labor saved. This looks like a little bit of a shear wall because they're bringing over blocking for 4 foot on centers. And you can see there's stud, or there's
Oh yeah, the marker.
blocking markings here.
Yep.
So like I had said, this will come down here. It'll get that strapping on. That panel's now flipped.
Right.
So the strapping's
How is that
already on
panel
it.
getting, this panel stands?
So this is a giant butterfly table.
Right.
So this actually
Slides
comes
over,
in on the track,
stands up.
comes up, flips back down.
Cool.
And it's perfect for this portion of the strop. You know, like back there, I don't know if you can see, we've got all of our cranes.
Yeah.
And here, we don't have that kind of infrastructure. So it's really nice. We've got the vacuum lifts and we've got that flipper table. And so it makes us a type of a horseshoe pattern how we're building these walls.
So you guys acquired this building, right?
We did, yeah. It wasn't made for us.
Right.
And so we spent some time developing how this is going to work in this facility.
Sure.
And with the post configuration, because those are all, it's a 40 by 30 grid, so it took us a little bit. But you can see that, so this was just pumped with cellulose,
Yep.
this whole cavity. It's the same as our other machine. We're flipped now. We actually, it doesn't look like there's headers required on this, so you're not seeing that header that we just saw there. So pretty compact, you know, again, making that the 3.5 pounds per cubic inch. We're going a little bit above.
Yep.
I mean, people sometimes say you're reducing your R value. Well, we're not reducing it that much.
Yeah.
I'd rather have it filled than not.
Yeah, because
That's settling.
otherwise, like you said, these are being transported over the road.
Right. And these ones even more than the others because they're standing vertically.
Right.
So it's just like a shaker box.
Yeah, I mean, if you think of that, if this is shaking down and it's loose, you could open up a gap up here, and now
Right.
you have, you know, a direct cold bridge.
Exactly. And so these guys, we just missed it, but they just routed this one, and
So that gets filled, slides
gets
down this
filled.
table, transfers over.
yeah, and this is where, you know, we have multiple wall systems. You saw the one in the beginning with the 9.5 inch stud. like I said, we've got the wood fiberboard. We actually do a 2x6 version too.
Yeah.
But what is always there is the 7/16. We have a chase, we have a stud, we have the insulation, and we either have zip or wood fiberboard on the south side. So there's many flexible varieties we can have.
Yeah.
In terms of climate zone, builders, what they like to see. But we've always got that inside skin, we've always got a chase on there. So the details for these guys out in the field stay the same. And when I say these guys, because all these guys go out in the field. They aren't just shop workers.
Gotcha.
And so pretty unique, very hard to probably understand on a business plan how that works.
Yeah.
Because what it does is it vacates certain spots here. But the invaluable part of it is the feedback loop.
Right.
That comes back from what these guys.
I think about it, same thing in our cabinet shop. Our installer will come back and help fabricate, and there's a lot of feedback there. I don't want to miss this. So he's installing these pieces of conduit.
Yeah, so he's putting the conduit on, then just taping over them. And so he's able to shove that through the cellulose, find the hole on the other side there, and then we'll tape the inside.
There is a hole on the other side, so that's fine. Yeah.
So that was actually routed. Tommy just routed that with the machine.
Yeah.
The other side was actually routed as well.
Gotcha.
In the exact same spot.
Gotcha.
So again, something, you don't have to get the hand tools out for.
Yep. So once that drops through, they tape over it, and then
they tape over it, and then we do a better job taping from the inside over there, because that's just going to get peeled off.
Right. Yeah.
They'll be putting an exterior box there.
Yeah.
But Tommy just came back from I don't know how many 1,000 square foot job down in Connecticut. I think, Tommy, do you know the square footage of Washeney? Do you know the square footage of Washeney by any chance? 9,600. 9,600.
I was like, 96,000?
But 9,600, he got the whole thing erected in 2 weeks.
Yeah, that's crazy.
And I mean, Tommy's an animal, but he had a good crew with him too, and I was amazed with the reports, and you should have seen this thing just go up and up and up. And it wasn't an easy build either.
Right.
It was,
well, 9,600 typically would.
But it wasn't just a box, is all I'm saying.
Yeah.
So,
Had a little bit of it.
So he had, and he had 4 guys the first week, 6 guys the rest of the time, but pretty amazing to see in that short period of time and everything working out.
Yeah.
And it's quite the accomplishment when you've worked on something for so many months.
Right.
And really these guys are working on multiple projects, but then they're going out on that. Tommy's the job captain, so we have what's called job captain instead of foreman. And, and we've got them all around. So, but everybody's at kind of different levels. Tommy's our most senior guy, and he takes out the most complicated jobs, and he loves it. And, we're bringing a deliverable to the site.
Yep.
And we're delivering it to us. We're the client, basically.
Right.
And so we're pretty hard on ourselves when we come back saying, hey, what do we do here? What's going on?
It's invaluable. That, like you said, the feedback loop is invaluable. So yeah,
let's continue on down here.
This gets flipped back over at some point.
Yeah, gets just flipped upright.
Gets flipped upright.
So this is the same bridge. That'll do the same nailing and sheathing, but if this were wood fiberboard, we'd be strapping it on the studs.
Here.
And this, and this would also get nailed off by the bridge. It actually inkjet marks for where the strapping belongs, and then it gets nailed off. So that bridge is actually a little more complex than the other one, but does some of the same requirements.
So that piece of conduit, right now, it's just floating in there.
Well, it's through the other side of the sheathing.
Right.
Yeah.
So, I mean, technically you could pull it out.
Yep.
But you're saying this gets stood up into here, and then that's when they're taping the inside wall.
Yeah, and you can see right here, so this actually tips up and goes on these little roller skate wheels.
Yep.
And this is automatically positions to one of our lanes, and so it's just a giant filing cabinet.
So this slides over, stands up, and then gets on this rail here.
Yep. And so,
similar to that one over there.
A lot of what we used to do, right now we're just streamlining it with windows. So we're taping the rough opening, flashing the rough opening, installing windows and doors.
Yeah.
But at one point, we were trying to side every single unity. And so we do all the siding here. We were actually doing a lot of the drywall too. And so we were much more involved in what the holdback numbers were for corner boards, water tables, drip cap.
Yeah.
And so we were siding all of our components, and that's what this buffer is really for.
Sure.
Is to be able to get in here and do that type of work.
But you're not doing that as
We're
much.
not doing that at the moment. We decided to focus on
the panel.
the panels, the air tightness.
It makes sense. I mean, I think that, you know, there's a thought process in building too, where there's components of a project that should be non-negotiable.
Yeah.
Like the envelope, the mechanicals, the thing, like the way it is structurally.
Right.
And, you know, some of the fit and finishes, siding materials, drywall materials, plaster material, like those things can be a little bit more in flux. Like they don't have to be, we don't have to be so rigid. If someone wants to do lime plaster over a painted drywall, that's not my, like, I don't have a preference over that. That's aesthetic. Where, like you said, you focus on the things that are non-negotiable for you guys as, you know, for reputation. Right. Someone's not going to judge your reputation based on the drywall.
Yeah,
It's the performance of the home and quality.
So you can see we're actually missing this window here. As you might know, some supply chain issues in the window area right now. But this is just a basic nailing flange window from Marvin.
Yep.
And so we're pre-installing the flashing and putting these in. But I'd say, you know, at least half, if not more, of ours are European tilt turn windows that we install. And so you'd usually see that at a mid-mount of the wall assembly. And so we're just putting that there, just, you know, kind of ensuring, excuse me, if they're going with lap siding, they can use that to get in between those joints. If they're going vertical, doesn't matter. Right.
And then you're just using this dowel material, caulking that, basically just prepping everything for, you know.
Right. And again, it's like a series, right? Typically, this is here because we're waiting on the windows, but typically coming down the first row, we'd be prepping the opening, and then we actually use these carpeted tables behind us, and we remove sashes, we put in the frame for the European windows, and then we're doing all that, and then we're putting back in the sash. We're doing interior extension jams a lot of times. So it's kind of like a step-by-step process as it goes down through here. And you can see these guys have their own carts for the up-high windows. You know, every single thing is labeled for their whole way of installing here.
So this wall is
it's tipped down sideways.
And then you're just using a low expansion foam around your window here.
Yeah. And that'll all be removed. And that's pretty much the end of the line. And you can see we've got 2 bundles started vertically, but that's how they get delivered to site. We're doing 3 or 4 at a time.
So you basically take a piece of dunnage, and then you're going to be standing these walls up, securing them to the dunnage.
Yep, and that'll all just be with truck straps. And we're putting a piece of plywood on the end to keep them vertical.
Yep.
But you can see the hole downs.
Right.
The routed holes for the Romex. But how easy is that to not, you know, what we used to have to do is lay out our wall perfectly.
Right.
And then in the center of the concrete drill, and then try to feather that on there where that's attached to the side of the stud. So this can all happen after the fact.
Yeah. So this must be for a timber beam?
That's exactly right, right? And again, so the timber's not going right through the envelope, it's ending there. There's framing behind it, but we're still able to do some sort of a horseshoe element behind it. So this just gets fastened to that, and we're still able to get insulation.
And you still have your notch for your electrician.
So a lot going in the wall, and this is probably a cabinet wall, like a kitchen or something.
Prep for the cabinetry, yep. And that's just, you're just taking a staple gun and
just wide crowning it, yeah. So that's the end of it, and then these things get shipped out. We shrink wrap everything. We ship it out.
They get shrink wrapped here?
Yep. Yeah. And just like all those bundles you saw outside.
The ones I parked in between?
Yeah. And you can see up there again, you know, much like that mock-up you showed in the beginning. Just a little around the details again. but it shows a little bit more. You know, we have the gasket, we have the Titan screw. This is a mid-mount window with an exterior pan.
Yeah.
Here's our screws in the floor system.
Right, that's that mock-up up front.
Yep.
And it's showing how this floor system's, while it's bearing on here, it's fastened into here.
Correct. And then you can see also the screw.
Yeah.
While that's not on the inside, it's fully on the outside, that
Right.
thermal conductivity all the way out. And this is just a little of the same, only looking in a bird's eye view of a corner. So this
Yep.
is an outside corner with a screw just staying totally to the outside, an inside corner with the screw totally going to the inside, and then just an inline joint, talking about penetrations and sleeves and some of our standard details around fastening requirements that we do.
Yeah, and that and for us, you know, we talk as a team constantly about like what should be our standard for how do we detail something. You know, we talked about condenses earlier and line sets. You know, it's like how do we have to create a standard detail for that, because everyone does it differently, and then or we end up relying on the HVAC sub where no disrespect to them, but all they care about is making sure that line set gets to their equipment and it works.
Yeah.
And it's the air sealing isn't something that's top of mind for them, so it's us as the builder or the GC to give them a penetration point and make sure that it's also an air sealed point.
Yeah, and we try to keep a standard selection of what it is for whether it be a line set, whether it just be Romex, whether it be
again going back, it's, you know, I think the biggest thing with all of this and panelization, thinking about all this and doing all of the preparation, thinking this all the way through before it hits what is an assembly line behind us. But the point of this is to understand how we achieve the best result, but also pull out the monotonous work from it. Exactly. Where it's like, rather than thinking about how I'm going to air seal around a line set, this is our detail. Until someone has a better idea, this is standard for us. Right. And it's going to be that process through everything, where it's like notching every one of those 2x3s for the electrician. It's like, until someone has a better idea, that's going to be standard.
Yeah.
Because it's saving the electrician time. And, you know, that for me, again, going back to what I said in the beginning, that's what has always been so interesting about Benson Wood and why I've always wanted to be involved and want to work with you guys on projects, which I hope we will. But that's like seeing the process firsthand and seeing how you're pulling out the work that, while some can argue is the craftsmanship, it's the work that makes this hard. Yeah. And the guys on the floor are able to still be involved with the entire process and not only here but also on site.
Yeah. And it's a different level of creativity, right? You're still using your brain, you're getting this education. Okay, we know how to build, but do we just want to break our backs until we're 40 and then being able to anymore?
It's the stubborn guys out there.
Yeah.
That, you know, it's like, no, I want to be cutting that roof by hand. It's like,
we can be so much more creative with it all, and I don't even think we've touched the tip of the iceberg here.
I fully agree, and I think what I said way over. What's it called? The hull?
The speed cut.
The speed cut. Who makes it again?
The Hundigger.
Hundigger. But like what I said over there, it's, you know, this is where you use the machine and then you push the creativity. And then you come up with a more creative approach, like that joint to reduce the hangers on the ridge beam, where it's like you even said it was structurally approved.
Yeah.
Where it's, you know, you start pushing the boundaries of how you do things. You know, all these blind fasteners. It's like that you have opportunities to build a better product and do it with technology.
Yeah, for certain.
Cool, Jay. Thank you so much, man.
Yeah,
Appreciate the tour.
Had fun.